Hey everyone, we're looking at assignment 82 today, finishing up our discussion about systems of inequalities, focusing mostly on going backwards. And yeah, let's see how it goes. Well, but maybe we should practice one going forwards first. All right, you talked me into it. So here's our system, and we can call this bell work. Please do y is greater than or equal to negative 2x plus 4, and y is less than or equal to negative x squared plus 4. All right, give it a try. Come back when you're done and ready to check your answer. So, my linear equation has a y-intercept of 4 and a slope of negative 2. So I go down 2 and over 1, and down 2 and over 1, and so I'm here at 2, 0. This tells me solid line, and if I test 0, 0, 0 is bigger than 4. No, 0 is not bigger than 4, so my shading goes up here. Next, we've got this down-pointing parabola that's been shifted up 4. There's negative 2, 0. Solid line as well. And then what about the shading for blue? Well, if I plug in 0, 0 again, I got 0 is less than or equal to 4. Well, this is true. This is a yes for the parabola, which means I shade inside the parabola. Where's the overlapping region? Do you see it? Here it is. Overlap. Done. That's our answer. Okay, so what about this one? Sorry, looking at my notes and I got distracted. What about, yeah, we're just going to graph it. And you can write the system of inequalities for it. That's supposed to be a symmetrical parabola. All right, there we go. And so this is 1, 0. This is negative 1, 0. This is 0, 1. It's a dashed line. And this one is 0, 4. This is 1, 8. And this is negative 1, 8. And where's our shading? Our shading is there. So, please write the system of inequalities for this. Or does this actually help to turn these off? No, that's not bad. Okay, I'll leave that off. So, how's it going? Any questions? Yeah, this is a downturned parabola, and the shading is outside. This is an upturned parabola, and the shading is outside. So, keep that in mind. And it may well be the case, since we know the vertex in each situation, that you want to be using ax minus h squared plus k. Remember to plug in the vertex, and then to plug in one other ordered pair to find a. All right, welcome back. So this one is y equals a x minus 0 squared plus 1, or y equals ax squared plus 1. Now, if I plug in another ordered pair, like 1, 0, I have 0 equals a 1 squared plus 1, or negative 1 equals a. So I've got my a value. A equals negative 1. That's one parabola. Oh, but wait, what about the shading? What about the symbol? Well, I know because this is a dashed line, not a solid line, that I'm just going to have either this or this. So which one? Well, let's see. If I plug in a point like 0, 0 minus 0 is 0. I get 0, I get 1. Is 1 bigger than 0? Yes, 1, well, 1, 0. I plugged in a 0 and I had 1. And I want this point to be a no. I want 0, 0 being plugged in for x and y to be a no. So I need that. That's a no. 0 is not bigger than 1. So I need that inequality in my parabola. Okay? Now what about that parabola? Well, we can start off the same way by saying y equals a, x minus 0 squared plus 4. And then we can plug in one of these other ordered pairs to help us find a. A 1 minus 0 squared plus 4. So I get a plus 4 equals 8, or a equals 4. So my second parabola is going to be 4 x minus 0 squared plus 1. Okay, but now what about the inequality symbol? And here's why. Well, if I plug in a point like 0, 0, this time 0, 0 is a solution. So I'm going to have 0, I'm going to have 1, and I want this to be yes. So I need that symbol. Don't forget the equal to, because this one's solid, this one's dashed, so it just has the greater than. And of course you could write this as negative x squared plus 1. And of course you could write this as 4x squared plus 1. Of course. I just showed it in that other way so that you, so that the people who needed to see where that was all coming from could see that. Okay, so what about this one? That is not what I intended. That's better. So this is negative 1, this is 1, this is 1. And I've also got a parabola here. And this is my region. This point, by the way, is 1, 4. Over here we have negative 1, 4. And this is not a parabola. This is, in fact, a semicircle. And while I understand that those points could certainly work on a parabola, you know, this is a semicircle. So come up with the system of inequalities, please. Okay, welcome back. So, for the parabola, y equals a x minus 0 squared plus 0. I put in the vertex. And now I'm going to plug in 1, 4 to find the a value. And I get that a equals 4. Fabulous. So we've got y, we've got 4x squared as the inequality, because there's no this and there's no this. But what about the inequality symbol? I can't use 0, 0, but I could use 0, 2. So if I plug a 0 in here and I plug a 2 in here, I want the result to be a yes. Why? Because the shading that I see is inside the parabola. So when I plug in my test point, I expect yes. So my test point is 2 and 0. I want this to be a yes, so I want that. Okay, there's my first inequality. What about the semicircle? Well, we know the whole circle would be x squared plus y squared equals 1. How do we know that? Well, we know that because the center is at 0, 0, and the radius is 1. But I don't want this stuff down here. So I really need to solve this for y equals. I know y squared is 1 minus x squared. And then when I take the square root of both sides, y equals plus or minus square root 1 minus x squared. However, I don't have both of these. I only have the positive part of the circle. So that's mine. Actually, I'm going to do it that way. So here's the semicircle equation. This time, 0, 0 is a yes. If I plug in 0, 0 into the semicircle inequality, I see the shading is inside. So I want the inequality to support yes when I plug in 0, 0. I plug in 0 there, and I have square root of 1 minus 0. And I want this to be a yes. So it has to be like this because it's equal to. All right, so that means my second is y is less than or equal to square root 1 minus x squared. You know, one of the things I like about these problems is that they're pulling together so many skills that we've talked about throughout the semester. Yeah, so I'm glad you're still working at not just learning the current material, but continuing to own the previous material as well. All right. How about this one? I kind of want to do some more forwards, but all right, we'll do another backwards one. What if instead of that semicircle, we did have two parabolas? So here's a parabola, and here's a parabola. And this point here is 2, 4. And this point here is negative 2, 4. This is 0, 0. And this is 0, 12. Okay, and I kind of want the shading to be here, but you know, maybe we should do this one a couple of times and change where the shading is. Ooh, I like that idea. So first one, we'll do shading between the two parabolas. So that shading is inside this parabola. That shading is also inside this parabola. So I'm going to be keeping that in mind. This one. Okay, so y equals a x minus 0 squared plus 0 has to pass through 2, 4. a2 squared. 4a equals 4, so a equals 1. So this is really just y equals x squared, because these are zeros, and my a value is 1. Now, I'm shading inside the parabola, that's this one, and all these points should be yeses. I'm going to try 0, 12. Is 12 is 0, and I want that to be a yes. So I do this. So that means this. Okay, there's our first inequality. Now, what about this inequality? Well, now the vertex is 0, 12, so that stays, but that becomes 12. And I can still plug in 2, 4. 12. 2 minus 0 is still 2. I still get 4a, but I have plus 12 here. I'm going to subtract 12 from both sides, and I get a equals negative 2. So now I'm looking at negative 2x squared plus 12 and a y. Now, I know that inside this parabola is a yes. I know that 0, 0 can be tested for this parabola. I plug a 0 here and a 0 here. I get that. And I want 0, 0 to be a yes. So I want to put an inequality here that makes this be a yes. And there it is. Don't forget, this has got to be there because this is a solid line. So now I've got y. I've got less than or equal to negative 2x squared plus 2. Oh, not cubed, 2. All right, there's our system of inequalities for this situation. Now, let's change the shading and see what that does. Let's make the shading be here. What do you think changes? Do I have to redo the whole problem, or can I just fiddle around over here? Does the changing of the shading affect the inequality on the down-pointing parabola? Why, no, it doesn't, because here, when this was shaded, that was inside the down-pointing parabola, and I'm still inside the down-pointing parabola. So that inequality symbol does not change. But because I'm now not here for this parabola, I'm not shading on the inside of this parabola. I'm actually shading on the outside of this parabola, and our overlapping region is here. Yeah? So this inequality, I need to do that. And some of you aren't comfortable with that, I understand. So let's take a look. Now, when we plug in 0, 12 with the up pointing parabola, now we want the answer to be a no. Okay, that's not a negative. So if I plug in 0, if I plug in a 12 and I plug in a 0, I should have this being a no. See? 12 has to be, that's not true. And that's why I need that inequality. All right. What if I have this shading? What if I have this shading? Again, that's not going to change the equations, but it does change the inequality. Which one changes? Well, I want 0, 0 to be a no for the down pointing parabola. So if I plug in zeros, I want this to be a no, and so I need that inequality. So that's got to change. And this one, I want 0, 12 to be a no. So 12, 0 squared, I want this to be a no. So I need that. And I had that from the last one. Okay? And the last possible shading pattern we could have would be shaded here. So what does that do to these inequalities? Well, I'm inside the parabola now, the up-pointing parabola. So if I put in a 0, 12, I want a yes. So 12, 0 squared, I want that to be a yes. So I need this symbol here. And what about here? Well, this is the downturn parabola, and there's nothing in there. If I plug in 0, 0, I should get a no. 0, 0 plus 2. This needs to be a no. And that's why that one does not change. Okay? Nice. So, how about, yeah, I actually kind of want to, I kind of want to do that one, but it seems mean. So I'm not going to do that yet. Instead, I'm going to say, will you graph x squared plus y squared greater than or equal to 9, and y is greater than x squared minus 9. Will you graph that system? Hey, welcome back. So circle centered at the origin with a radius of 3. See, I wasn't kidding when I said you really need to be comfortable with this graphing all year. Nice. And then we've got this parabola. Oh, let's do the shading. Does 0, 0 work? Is 0 bigger than 9? No, 0, 0 doesn't work, so we're shading outside of the circle. Okay, and then I need to graph this parabola. Well, I know way down here is this point called 0, negative 9, and that my parabola goes from there. Do you remember that part of I said, I think it was in the last video, where students often don't extend far enough? And so if I only graph this down here, there's a lot of, yeah. So here's what I notice. Where does this have x-intercepts? Squared plus 9. If I plug a 0 in for y, sorry, that's a minus 9. X minus 3. X plus 3. Oh, look, my x-intercepts are 3 and negative 3. So my parabola goes like that and touches here and here. Okay, so, and which way do I shade? Does 0, 0 work in this situation? 0, 0, minus 9. Is 0 bigger than minus 9? Yes. That's a yes. And so that means the shading goes on the inside of this parabola. Okay. So where do you see the overlap? Well, I see some overlap here. And I see some overlap here. So I could describe it using words by saying inside the parabola and outside of the circle. Okay? Nice. So you need to be able to go both forwards and backwards, but going forwards when you're given the system of inequalities is the more conventional approach. What if I had this one, 3, negative 3, 0, 9, but then I had this one. Where's this one? There's this one, and my shading is here. This point is 0, 1, and I need to give you a second point there. What's my second point? 2. Let's do 5. I think so. Let's see. 2, yeah, 2, 5. I guess this would be negative 2, 5 as well. Okay, so, go to. You've got the graph, write the system of inequalities. Okay, welcome back. So the down-pointing parabola, y equals a, x minus 0 squared plus 9. And if I plug in 2, 5, the 5 equals a, x squared plus 9, or negative 4 equals, oopsie, I plugged in a 2, 5, sorry. So this is 4a plus, I subtracted the 9 already. All right, so that's 4a, and so a is negative 1. So my first inequality is this, which I can tidy up to be y, negative x squared plus 9. Now, what about shading? Well, if I plug in 0, 0 for that down-pointing parabola, there's no shading there. That should be a no. This should be a no. That's a no. Oops, I have a solid line here, so I need that. Okay. Now, what about the other parabola? Our up-pointing parabola. Well, that's y equals a, x minus 0 squared plus 1. If we plug in that second point, we get 5 equals a, 2 squared plus 1. We get 4 equals 4a, or a equals 1. So that's a 1. But what about the inequality? Well, on the up-pointing parabola, my shading is not inside that parabola. So I want, this is outside of that parabola. This 0, 0 would be yes, but I don't see that shading. I think it might be easier on my brain if I said inside the up-pointing parabola is a no, so pick a point inside. And so I have 0, 2 squared, no. This is 2, this is 0 squared plus 1. And I want this to be a no, because at this point there's no shading inside the parabola. So no means like that. Okay, so I've got y less than or equal to x squared plus 1. And there's my system of inequalities. All right. Well, I hope that you have learned some math this semester. I hope that you're feeling a little more confident in your algebra skills. Next semester, we move on to trig. And I will say that those of you who don't feel very confident right now with your pre-cal and wished you were more comfortable, I would certainly encourage you to ask more questions between now and the end of the semester. But also, I want to say, you know, we used to actually teach the trig before we taught the pre-cal um, because there's almost no pre-cal needed in trig. You have to be able to factor a quadrilateral. I'm sorry, you need to be able to factor a quadratic function. You know, something like y equals x squared minus 5x plus 6. And solving that equation. We'll need that next semester too. We will need our transformations because we're going to have some new reference graphs to work with. But that's about it. Yeah, I don't think we need much of anything else from this semester, next semester. So don't worry about trig. I'll say that there's a lot of memorizing that goes to trig, and there are 3 magic secrets to trigonometry. 1, know your unit circle values. And I actually think that one of the reasons why uh, I've tutored a lot of kids in trig from other schools is because their teachers don't make them memorize unit circle values. How do you understand this? Understand it in this context. What if your elementary school teacher did not make you memorize the multiplication table? And so that when you got to 6 times 7 in your life, you always had to pull out a calculator. That would make math much harder, wouldn't it? Well, the unit circle values are like the multiplication table. We just need to know them and be that comfortable with them. Never a question of having to look them up. They should just appear in our head. We know them so well. So that's going to be one task we're focusing on in January. The second magic secret of trigonometry is to know your identities. This is kind of like knowing the theorems in geometry class, where it was really hard to do geometry if you didn't know the isosceles triangle theorem. But once you knew the isosceles triangle theorem, yeah, geometry got a little easier. And so too, we're going to have some identities, and you're going to need to know them. And then finally, draw a right triangle is going to be chapter 4, and draw a triangle is going to be chapter 6. So, yeah, these are the 3 big magic secrets to trigonometry, and I can't wait to take a look at them with you. Take care, everybody.